Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, Tarun and I catch up with Uma from Succinct. We talk about the different products they have shipped in the last year, from the work they did on ZK Bridge infrastructure, the Blobstream X product with Celestia, the Succinct platform, the Prover networks, and their recent announcement about SP1. We discuss how all of these products fit together, what prompted their development, how the competitive landscape looks, the role of the provers, sequencers, aggregators of the future, and more. Now, before we kick off, I wanted to highlight the ZK jobs board for you. There you can find jobs from top teams working in ZK. So if you're looking for your next opportunity in the space, be sure to check it out. And if you're a team looking to find great talent, be sure to add your job there as well. We also have our upcoming ZK Summit event to look out for. It's happening in Athens on April 10th. The event is shaping up. We've been adding speakers to the website, and we'll share the schedule there soon. As always, this is invite only and space is limited. There is an application process, and you need to apply to be eligible for a ticket. If you've already received an invite to buy your ticket, be sure to secure it. We expect the event to sell out. I've added the link in the show notes if you still want to get an application in. Hope to see you there. Now, Tanya will share a little bit about this week's sponsor.
Launching soon, Namada is a proof-of-stake L1 blockchain focused on multi-chain asset-agnostic privacy via a unified set. Namada is natively interoperable with fast finality chains via IBC and with Ethereum using a trust-minimized bridge. Any compatible assets from these ecosystems, whether fungible or non-fungible, can join Namada's unified shielded set, effectively erasing the fragmentation of privacy sets that has limited multi-chain privacy guarantees in the past. By remaining within the shielded set, users can utilize shielded actions to engage privately with applications on various chains, including Ethereum, Osmosis, and Celestia, that are not natively private. Namada's unique incentivization is embodied in its shielded set rewards. These rewards function as a bootstrapping tool, rewarding multi-chain users who enhance the overall privacy of Namada participants. Follow Namada on Twitter @Namada for more information and join the community on Discord, discord.gg/Namada. And now, here's our episode.
So today, Tarun and I are here with Uma from Succinct. Welcome back to the show, Uma.
Thanks for having me.
Hey, Tarun.
Aloha. Excited to talk about proving networks and more.
Yeah. Uma, you've been on the show before. We did an interview about Succinct back in November 2022, so over a year ago. I'm going to link to that in the show notes. In that, we do a bit of a background on you and the project, and I think John was on that one as well. We did a quick interview, or like a sort of a casual catch-up interview in July 2023. So this is your third time on the show. For today's episode, what we want to do is a catch-up on Succinct, because since you were on in November 2022, the project has released all these different products or initiatives. Back then, we were talking all about bridges, but since then, there's something called Blobstream X you worked on with Celestia, some sort of developer tooling for ZK, a Prover network / marketplace, and then, last week, and what kind of prompted this show was the announcement of SP1. So, I'm really excited to dig into all of this with you.
Yeah, for sure. There's been a lot of updates.
Quick disclosure, I am an investor in Succinct, as Tarun is as well.
Yes.
When we had you on in November, the main topic was kind of these like ZK light client bridging, and we were talking about Gnosis. I think maybe where we can start is what happened with the bridge work that you were doing, kind of what happened since.
It's been really fun. I think, as you mentioned, we've built a lot of stuff and shipped a lot of stuff, so it's also been really busy, especially with our recent releases of like the plans for the Prover network and also SP1. It's been really exciting to like see people finally using it, especially with SP1. Like, I think the open source community really, really loves it and has been really excited by it. And even internally, I think our team just using our own product has been really exciting because we've kind of left all the hellish circuit stuff behind. So that's also been awesome.
Nice. Going back to that episode where you introduced Succinct, at the time you were working on the Gnosis bridge And generally, I mean, Succinct, we categorize Succinct as a bridge company, a bridge-focused company. Can we talk a little bit about what came out of that time, working on bridges? Did you do other bridges? What stage are they at this point?
Yeah, so when we started Succinct, I think John, my co-founder, and I were really interested in ZK broadly and how ZK can be useful to like blockchain infrastructure applications, et cetera. And I think bridging at the time was really top of mind for a lot of people because I think the Nomad hack has just happened like that summer, and ZK bridging was like just becoming to be possible. So we were focused on that. We thought that was like a really great application of ZK. So we, as you mentioned, we had built out this ZK Ethereum-like client for that right now is actually helping secure the Gnosis bridge from Ethereum to Gnosis. And then from that time also came work with Celestia on building a ZK bridge for Celestia to connect Celestia to Ethereum. So we did ZK Tendermint because Celestia is a Cosmos chain, and so they have the Tendermint consensus algorithm. And then we've also been working with Avail, which is also a data availability layer, and doing a ZK bridge for Avail. They're using Substrate, like the Polkadot SDK, I guess. That has a different consensus mechanism. It's called like Grandpa. And so we built this like ZK Substrate / Grandpa thing for them. I think from November 2022, which is when I was on, to like, I guess, last summer, so like summer of 2023, I would say we were really focused on like building out all these bridges. We obviously didn't end up building a consumer-facing bridge because I think at the time, like doing the ZK stuff was just so difficult. Like we didn't have time to even think about building a consumer like facing bridge on top. Like we spent all of our headspace writing these circuits and like, writing all the ZK stuff that ultimately we were like, ZK will end up in every bridge, but like it'll be more like, take all the existing bridges that are out there and then integrate ZK into them as a security mechanism rather than just like only being one ZK bridge. I think that doesn't make that much sense actually. So yeah, that was like our big kind of conclusion from that was like, yeah, ZK is awesome, really hard to use, but it'll end up getting adopted by like everyone just using it, not us building like the only ZK bridge.
Was that at the time an actual idea, though? Like when you were doing this, you're building the infrastructure that could power these user-facing bridges. Had it crossed your mind to try to launch a bridge project?
Yeah, I think even when we started the company, I think John and I really loved ZK. Like that was the thing that was exciting to us. I know a lot of people, like they viewed us as a ZK bridge, but I think that's not because we actually were one. I think that was more just like people saw ZK bridge and got excited and were like, Succinct's a ZK bridge. But I think we were always just much more ZK, much more so than bridging. Like ZK is the thing we were really excited about. ZK is like why I got into this space. ZK is like what I wanted to work on. So I wouldn't even ever say that I was a ZK bridge project.
Okay. I think I'm definitely guilty of categorizing you guys in the bridge category. Apologies. What I am noticing that's interesting is last time, or when you were on back in November, you were trying to tell us not to use ZK anymore. Do you remember? It was like succinctness.
Yeah, it's true. We still are not really using the ZK property as much. Yeah, I guess that is the inspiration for the name of the company.
Fair. I mean, I know we're going to get into all of the new work coming up, and I totally appreciate that most of it it's focused on the succinctness side of Snarks. But do you think that privacy will be something that you are interested in, or like even in SP1, is privacy one of the things that you can kind of offer?
I think privacy is like actually still really interesting. So SP1, I think we can pretty trivially add privacy to it. And so I am excited about that. Actually, there was an open source contributor who was trying to generate SP1 proofs in WASM. They have like a PR in our repo so that you can do client-side proving with SP1. So that is like definitely something we do want to support. And I think it's like very interesting.
Nice. All right. So we just talked about some of the kind of infrastructure work that bridges could use, the Ethereum light client and all of these other light clients. I have one question on this, which is more to do with just DA layers. Why does Celestia or Avail need a bridge to Ethereum? Like, is this work that ended up being put into the blob stream work? Is it for the actual data availability? Basically, I'm trying to figure out, is this a bridge of like a token bridge to Ethereum, or is this like the DA bridge? Is this bridging their actual offering to Ethereum?
Yeah, that's a good question. So for Celestia, right now, if you're a DA layer, so if you're a rollup using Celestia or Avail or whatever DA layer, as part of like the fraud proof mechanism or validity proof mechanism, you need to be able to show like this data was posted on Celestia. And so that's why there needs to be this bridge from Celestia to Ethereum, so that as part of like, if your rollup settling on Ethereum, you have access to like information that, oh, this stuff was posted on Celestia or Avail or whatever other DA layer you're using. So that's why they need a bridge, a unidirectional bridge from a DA layer to Ethereum. In Avail's case, they're also using it, I believe, to bridge their native token to Ethereum as well. So they're using our Ethereum-like client on Avail and the Avail-like client on Ethereum to do bidirectional token bridging as well.
Got it.
But for Celestia, it's just a unidirectional DA bridge.
Then is ZK Tendermint, is that kind of the same thing as Blobstream? If it's only that one that like, is it the foundation of Blobstream X in some way?
Yeah, ZK Tendermint is like the core of Blobstream X, and then Blobstream also does some additional stuff on top by like hashing all of Celestia's data routes to make it more easily available. So yeah, Blobstream is like a small thing just like on top of ZK Tendermint.
Okay.
So actually, one thing I've been hearing about a lot in kind of this whole like aggregation layer type thing that people have been talking about is this idea that the DA layer would also store some type of like execution proofs. Like, you have your DA, the DA, maybe goes via something like Blobstream, and then the execution side generates a ZKP that like, hey, this state was used in this function, and like this is the output of this function, and then it tells the DA layer like, okay, like it writes some proof of execution like of usage. And I think that this is like good because it like lets you do this like aggregation type thing at the DA side. Is this anything you've been thinking about, like, or like, because like a lot of what you're talking about seems like almost relevant to doing something like that? So,
interesting. That is like new to me actually. So, I haven't heard of that. I think it would be like build upon like some of the DA stuff. It sounds like a bit of like a generalization of the bridging we're doing right now. But yeah, that is like a new concept to me.
Okay, cool. I was just wondering because like I feel like we're talking about these one direction unidirectional bridges, right? I feel like you're missing out on a lot of things you could maybe do if you had bidirectional, in the sense of like the DA layers can respond. And so like I've been thinking a little bit about like applications like that, which would be like a lot more efficient if you could like have some proofs between the two systems about properties they can't validate about each other.
Oh, interesting. Yeah, I see. Yeah, that's definitely possible. It'd probably be pretty easy to build with SP1, honestly.
Well, we need to get to talking
not to show
SP1
too
next.
hard. Yeah.
All right. I don't know if this timing is completely correct, but I know that in my mind, there's Blobstream X, and then there's the Snark toolkit or this developer tooling. Maybe, I don't know when each of those came out, because I remember the announcement from Succinct basically being like, there's now this way to kind of easily use these tools. Tell us a little bit about what that is.
Yeah, so we had been like working for a while on our original Ethereum Lite client, and then also this Lite client for Celestia and for Avail. And yeah, the ZK developer experience, even on our own team, like obviously we have a pretty sophisticated team with a lot of expertise, and it was just getting super complicated to like manage all these like circuit deployments. Like we realized, for example, that like every time you build a circuit, we generally worked with pretty large circuits. We'd have to like spin up a whole new machine, store the artifacts, manually upload them to S3, and do all this like really manual stuff. And it was just like a really horrible developer experience. And so also at the same time, a lot of random teams would come to us and say, hey, can you write me a circuit for XYZ? And we were just like, we don't have the bandwidth for that. We're like a pretty small team. So maybe you can try doing it yourself. And they're like, okay, well, it's like too hard to do it ourselves. So that's kind of why we built the Succinct platform, which I think is what you're referencing. And we launched that around, I think, November.
Okay.
And it was really this like ZK developer tool for like, people like ourselves or any ZK developer to make it really easy to like develop and deploy like any ZK application. So it just made it a lot easier where, okay, once I have like the circuit, I can go to like the platform, I can connect my GitHub repo, and then it takes care of like building stuff. Like circuits have artifacts like the prover binary and things like that. So like takes care of all of that like kind of infrastructure around actually deploying a ZK app to production. And yeah, that was kind of the inspiration behind it, was like born out of a lot of our work on building all these ZK bridges and realizing like the ZK developer experience is like really bad. And like we were like trying to fix that with like Alpha.succinct.xyz, which is our platform.
One thing I think that is kind of interesting is this does remind me a little bit of, to some extent, AI tooling. And I guess you had a tweet about this, so maybe I'm giving you kind of a layup for that. But this idea that like, hey, the people who are like building applications or trying to use the systems end up going down the stack. So they like start at the top trying to like build the application. But then as they try to build multiple applications, they like have to keep going down and until they're like doing, sort of the full stack of infrastructure. In some sense, it seems like that was your journey here, right? Like you kind of making different things. Some of them you did via circuits, and then you kind of like went downstream. So how do you kind of think about the journey of going from like building an application using ZK to like trying to overall make you end up building developer tooling and a VM effectively?
Yeah, I think that's like exactly right. I actually used to do a lot of AI stuff, so I totally agree with Tarun. Like there's this AI company, Hugging Face, that they were building their own AI chatbot, and then they ended up building a platform really similar to like our Alpha.succinct.xyz platform, because they realized like building and deploying with AI was like too hard. And we had a really similar journey where we like just kept on going down the stack to fix more and more problems with ZK. So for example, our platform was like made our lives a lot easier for building all these bridges. For example, there's a few developers on our team who are like focused more on like deploying these bridges to production, and like they were using our platform and iterating with it. They were kind of like the first customers of it, and it's like helped them tremendously. Like stuff that used to take them like a month or something, now it takes them like an hour, because you can just click a few buttons and then everything's like saved for you, and like you can like see where all your verifiers are deployed on chain. It's really easy to like monitor proofs. It's really easy to see like what's going on. And so, yeah, stuff that used to like take them months is just like a really simple for them now through our platform. And then, yeah, the VM that we're building and like the prover network is like, I would say maybe even another layer down the stack, and like solving the other biggest problem with ZK, which is writing all these circuits is like really horrible, just very difficult and requires like a lot of specialized expertise. And then with the VM, like you can just like write Rust and normal code. And so after we built the platform, we were like, okay, this platform's really awesome. It makes it really easy to like deploy stuff to production, monitor it, request proofs, really nice APIs. Like we have like a built-in proof explorer where you can see all the proofs and track everything, which is like really helpful for our customers because they can see like, oh, is there a problem? Like, what's going on? But then we were like, okay, the biggest bottleneck to people using this offering is like no one wants to write circuits, which is like totally fair because like it's really difficult. And then we were like, okay, so the answer to that is like a VM. And so that's why we were really inspired to build SP1.
When you talk about this, like the Succinct platform, Alpha.succinct.xyz, I think you said, which systems are actually supported? Which like circuits is it only limited to the ones that you're working on, or is it like more general?
So it's built like really modularly. So it actually supports a bunch of different proof systems right now. It supports CertCom, Gnark, and Plonky 2.
Okay.
A lot of our current stuff's built in Plonky 2. So it has really great support for that, but it actually supports a variety of options. And it's pretty easy to add new proof systems to it. And then it's not just our circuits. Like there's a bunch of teams using it actually. Like last week, I think we also announced like Wormhole's using the platform. So they had written their own circuits for their Ethereum-like client in Plonky 2, and they are deploying it through the platform. I think there's a team from Near using it to build like a ZK bridge for Near. And then there's like some other random applications on it. So there's actually a few different external teams also using it for their own circuits that they've written.
Does it have any sort of security analysis of these things? Like, given that people are just going to kind of use the tool to generate the code to do this, I guess? Like, is there ever like a concern? Like, what if there's a problem in any of these? Did you get it audited?
Our platform's just like infrastructure, so it's not like security critical. It's just like a method of like saving circuit binaries and like APIs for requesting proofs and like large scale distributed proving and things like that. Like there's no your circuit is what ensures the integrity of what you're proving, if that makes sense, which is independent of our platform.
I see. Okay.
So the circuit developer has to go get audited.
Yeah. The circuit developer gets audited. Our platform just like helps you deploy whatever.
All right. That makes sense. I think I thought of it almost like an end-to-end, like that you go on this and it sort of churns out the entire thing for you. But I get it's more like it's tooling around a circuit.
Yeah, exactly.
Okay. So then we can move on to the next thing that you guys announced, which was the Prover Network. I saw that as like a Prover marketplace, but yeah, what is the Prover Network? And you sort of painted a bit of a picture of like going down the stack, but how does it actually like from the Succinct platform where you built like the tooling around it? Why then a network? Actually, let's define it. I don't know if we've talked that much about it on the show. Uma, how would you define the Prover Network?
Okay, maybe it's good to take a step back and think about like, okay, when a proof gets generated, there's like actually a bunch of different actors and like a bunch of different steps. And like we kind of call that like the proof supply chain. I think actually Nick Matthew at Figment wrote an article about it. But basically like you have, of course, your application that's like requesting a proof. And then they're using like some sort of proof system to like, you know, express like their logic, whether it's like a circuit or a VM. Then they request a proof. Then the proof gets generated. And then it gets like potentially aggregated. And then it lands on chain in the application. So there's like this like proof supply chain with like a bunch of different actors. And so our platform right now is like a very simplified proof supply chain. Like you deploy your circuit on the platform. And then when you send requests to like the platform, we generate the proofs on our infrastructure, right? So it's kind of like we are the entire proof supply chain.
I see.
Now, I think that's not like super sustainable because, well, first of all, like, you know, we could maybe price it, but then like today, like, you know, I'm just like, oh, I decide some number that's like, hey, your proof is going to cost this much. And it's not even like super clear, especially as the proof supply chain gets like a lot more complex. Like I think hardware is going to be like a really important part of that end game. There's probably even going to be a diversity of hardware providers. Like, are we going to be the best position to provide proofs at the cheapest prices? No, probably not. Also, for example, like if you're an application, do you want to go talk to like 20 different hardware providers and figure out who has like the best prices or capacity or whatever? I don't think that makes that much sense. And so like, basically, I kind of view like our Prover marketplace/network as like this protocol and set of standards for kind of taking our platform and making it into a protocol. And like, it's also a decentralized protocol, which is nice because I think a lot of bigger projects that use us also want decentralization. But it's just like this protocol for having all the people in like the proof supply chain kind of like coordinate and talk to each other in like one place. So that's kind of how I view it, if that makes sense.
But you just mentioned that it's like taking the platform turning it into a protocol. But do you mean that Succinct platform, like the one that's building the tooling around circuits? Is that what you meant by platform? Or do you mean something else?
Yeah. I know. Yes, I do mean that. Like I kind of view like our current Alpha.succinct.xyz as like our Prover network alpha, actually. Like I think today, if you use Alpha.succinct.xyz, you deploy your application there, and then we fulfill all the proofs for you. But over time, like once our like Prover network and marketplace goes live, you can imagine that there will be like this competitive auction for a bunch of different people to provide proofs that are requested through that interface. And so like in the fullness of time, I kind of view Alpha.succinct.xyz as like a deployment interface to our network, if that makes sense.
I didn't think of it that way when you described it, sort of it creates things around a circuit. I've definitely talked to a few different teams doing Prover networks, but I don't actually know what the exact thing that is happening, like what part is being proved. I thought it was kind of the whole thing. Like I thought that it was like they sent you the thing that needs to be proved and then you generate the entire proof in the Prover network. But if you're using this platform, which from what I understand, like it only generates something around the proof. It's not the full proof.
No. Right now, it does generate the proof. Maybe it's best to just start with, like, what is the prover network doing? The prover network is something where, like, you deploy an application on the prover network. You say, like, here is something that will generate a proof. Like, here is, like, how you can generate a proof. So it's, like, some proving binary or, like, some sort of circuit artifacts. And then you have this, like, competitive marketplace, auction, whatever, mechanism. And you have this, like, set of people who are provers who, like, actually generate the proof. And then it gets verified and then they get paid, right? So that's, like, very simple to understand, right? It's like you're a marketplace where, like, people are sending proof requests and you're matching them with, like, provers who are, like, generating proofs. Our platform makes it easy for people to, like, send proof requests. Like, it's just, like, a set of, like, it's, like, tooling to make it easy to, like, deploy your circuit, send proof requests, whatever. I view our platform as, like, something that, like, makes it easy for anyone to want a proof. Because, like, right now, if you want to send proof requests, like, there's no, like, unified standards for all that stuff.
Got it.
And then, like, right now, our platform, we, like, run all this infrastructure and we are generating all the proofs. But that's not, like, necessarily the most sustainable or desirable thing. And so in the fullness of time, when we have a prover network, anyone will be able to, like, generate proofs. And so in that sense, Alpha.succinct.xyz is kind of like our prover network alpha. Like, it's, like, kind of like what is live of the network today.
I see.
And then over time, as we, like, build out more of the protocol and build out the auction mechanism, hopefully with Tarun's great help, we will be able to, like, turn that into, like, a more full-fledged network where, like, anyone can, like, help provide proofs, and it, like, provides way better prices for users and things like that.
I see. So it's sort of one piece along the chain. In those prover networks, the proof generation, like, I'm assuming if you are kind of creating a prover network, you're creating almost like the client software, the prover software that a prover would be running.
Yeah.
Would that be then like a next step for you guys? Like, is that what, when you kind of announce a prover network, is that what you still would be building?
Yeah, so I think, like, the actual node software that provers in the network run can be, like, pretty minimal. Like, basically, if you're a prover, you would, like, what do you have to do? You have to basically participate in this, like, auction and, like, say, hey, I'm willing to generate a proof for this price. And then you have to, like, be able to download, like, the circuit binaries and artifacts and then actually, like, run them and generate the proof and things like that. And so we will have to build, like, some node software, but I think that part is, like, can be fairly minimal.
Okay.
Do you think there'll be, like, enough standardization such that, like, the infrastructure cost to, like, the actual provers is, like, relatively low? Or do you think it will end up being this type of thing where, like, okay, some particular proving systems are, like, extremely bandwidth intensive or extremely compute intensive, but are not memory intensive. Some are much more memory intensive. And, like, me as the prover participating in the network, I might get a request from all these different particular systems, and then I effectively have to have, you know, multiple different types of infrastructure or hardware to generate them. How do you think about, like, the homogeneity versus heterogeneity of, like, the networks over time? Because I think that's sort of obviously a important factor.
Yeah, that's a really great question. So I think it might end up looking somewhat heterogeneous, actually, but I think the way we've been thinking about architecting it is very similar to how, like, EigenLayer has architected their AVSs, where if you're a node operator participating in EigenLayer, you can opt into, like, which AVSs you run, right? So, like, you only choose, like, hey, I'm going to run these X services because it makes sense for me. And I think nodes, like, provers in our network will be really similar. Like, you can say, hey, I'm cool generating blob stream proofs. I'm cool generating, like, the avail proofs. I'm cool generating, like, this other proof, and, like, that's all I do, and I just participate only in those. You could also have really specialized provers that are like, hey, like, my hardware is, like, best suited for VMs like SP1, like, I'm just going to participate in that. So I think it might end up being pretty heterogeneous, but I think that's actually okay because it's, like, opt-in and it's just, like, a marketplace, right? So, like, that's fine, right? As long as you induce competition amongst the people who are participating, like, it's fine if not everyone's participating in every single, like, proof.
Can we talk a little bit about those auctions? Kind of where are you at in your thinking around that? Is that something like the game of the marketplace, almost the incentives, the making sure that, like, the people who are doing these proofs can actually earn enough revenue to at least cover their costs, hopefully make something. Yeah, how are you thinking about that? I mean, I'm guessing you have to sort of predefine it, pre-think out like a lot of the nuance of that.
Yeah, so we've definitely put a little bit of thought into like how to design a great auction. I've actually talked with Tarun a little bit about it, and his other collaborator, Kay, as well, and also talked a little bit about it with all of Tarun's like mechanism design auction people, which has been a lot of fun. So we've started thinking about it. I think there's like you have to be pretty careful with like how you design the mechanism, obviously. So in short, we've started thinking about it, but I think we're like hoping to collaborate with like a lot of like really great people who have like a lot more expertise in like auction design and stuff like that, to make it like really robust, for the long term. But we also might just like start with something simple and then like iterate,
I think the interesting question is like, if you have something like what you talked about where people opt in and out of particular services, like, can you just have per service auctions or like per type auctions? Almost like, if I think about like nodes on AWS or Google Cloud, like there's like preemptible prices for each type, and sort of that's like the implicit auction for each type. Or do I need to actually like do something across the different types because like, I'm doing aggregation across multiple networks, right? This is also maybe slight tangent. Why I've been trying to understand all these people talking about like these, I think Polygon in particular has been talking about these like aggregation type of things.
But all of
like
them have it, right?
Yeah. And like aggregating over multiple rollups. And like, I do think you run into this issue, at least of what I'm talking about, where you actually make like the economics a lot more complicated for that versus like the single node one. And like, I think this heterogeneous versus homogeneous question is like fundamental to that in a lot of ways.
Yeah, that's really interesting. Yeah, I think it would be a lot easier if everything was homogeneous for sure. But I just think, our opinion, and this also kind of informs like our SP1 design and stuff, is like, in the fullness of time, it's just not necessarily super sustainable to be like, this is the only proof system you'll use, or like, this is the only VM you'll use. Like, ZK is just like so full of like innovation, and it goes so quickly that like, that's why on like our platform and also like our prover network, like we're supporting, everything. So we want to support all these different proof systems. We want to like have a mechanism that's like robust to this heterogeneity, I guess, because I think that's like the most sustainable way to design it. I think the auction will probably, in its simplest form, just look like per type, kind of like what you said. Like AWS has like spot pricing just like per CPU type, and I think that should actually work reasonably well. But yeah, I think it is an interesting question, like whether there's something like more optimal to do.
One thought that I've been having around the prover network, prover marketplace kind of concept has been like the role of the shared sequencer. Like the shared sequencer story says, and this sort of speaks to what you're saying, Tarun, like that's the I think what do you call it? Accumulation?
Aggregation.
The aggregation. So like, to me, that's sort of like a shared sequencer's level, right? Is that kind of what you'd also call it?
Yeah, I actually think this is going to be one of these very weird things where the terminology for what a sequencer is going to get unbundled over time.
Okay.
It's like right now, the sequencer is like the single point, and these aggregation things are like, hey, I have a sequencer sequencing rollup 569, but this sequencer is not like a powerful enough sequencer. Like it's not sequencing OP or ARB mainnet, and now it's getting aggregated with the OP and ARB mainnet sequencer. So like all these designs for like either shared or decentralized sequencers are kind of like implicit in all of them, like unbundling the roles, the tasks that a sequencer does into kind of substituent jobs. And I think we're going to get words where like sequencer will equal the union of the set of tasks. And
all
like,
of them.
And each thing will be some subset.
So like a sequencer, this is why, because like I was trying to think like who will be doing the proofs for the rollups. Like I'm assuming it's the sequencers are running the proving node software as well. And then you're talking about like these nodes choosing which prover software, but then they're also in this like sequencer hierarchy. But Tarun, do you think there will be like a meta sequencer original, like eventually that kind of emerges, some sort of like mecha? I don't know what you call this, but like the Power Ranger of all of these tools somehow.
Power Ranger. Wow.
By the way, that's a weird reference. That's like after my time. Like I was too old for Power Rangers.
I think I was exactly the time of Power Rangers when I was like 4
Yeah.
or 5. If this aggregation type of thing is the final state of like the best trade-off when you have heterogeneous demands. When I say heterogeneous demands, I mean, let's take Solana as one type of demand network, right? Of like people want low latency and like sort of are willing to take more variance in their fees versus say like Ethereum mainnet, which if it's mainly just settlement plus some very large trades, settling like Uniswap X style trades or something. And then layer 2s, which have a lot of demand, they maybe have like latency constraints, but they're going to be very heterogeneous, right? Like Base is going to be a very different roll up than like Farcaster chain, which is going to be very different than right? Like if you just look at their loads, they're going to like look very different, right? So I think if you believe in the long run that everything will just be aggregated ZKPs, then I think the final boss is kind of what Uma is talking about, of like this network of people who are generating the proofs, and then part of the network is assigned to do the aggregation, part of the network is assigned to do the individual things, and like you stake and you get allocated to each of those, and the final boss is just like that network, right? And so there's 100%. A world in which that could be the end state if like everyone, if this kind of aggregation view of the world is true. It's definitely something that feels like the final boss, but like I don't know how close we are, but Uma probably has a much better prediction about it.
No, we're close. We're close to Rune. No, I so agree with you. Like, I feel like in like this modular thesis, like modular stack, there's going to be sequencing, which is just ordering, right? Like, even if you look at like Espresso's, Docs, or other decentralized sequencers, like they're just doing ordering. They're not doing any proving. Those nodes are optimized for like super high throughput. Like, let's just order stuff. Then, okay, now let's like prove all the stuff that's been ordered. And that's going to be like going through this like proving network, right? And so then the proving network is going to like coordinate like, okay, who are the hardware providers and like who are these like operators who are actually going to be like generating these proofs? As Tarun said, exactly, like aggregation is just another like job type on the proving network. It's just like, hey, now we have a task that requires an aggregation proof. So that will get coordinated all on the proving network. And then it gets settled on like Ethereum or whatever other like chain is being used. Maybe the DA is posted on like a separate layer. So yeah, I think it'll be like sequencing, proving, settlement, DA is kind of like the ultimate stack.
But this is the thing, is like going back to that concept of an agent. This is sort of the way we think about it, like a prover, a sequencer. Like I imagine that still being like one entity in a way. Or do you guys see that as like truly like you go through this marketplace and then this marketplace and then this marketplace is all different entities running these agents? Or like I'm speaking a little bit because of the ZK validator. Like we're just thinking like from the validator's perspective, as we explore this kind of stuff, we sort of imagine we could run a lot of these things at the same time. Maybe there's teams that build, or maybe the teams that are kind of developing this build like a combo sequencer, prover, DA, check. I don't know, all of that. I guess I'm trying to figure out, is there a reason one would want to separate them? Or do you want to put them together?
No, you could imagine a network where you're like, imagine a proof of stake network where like we stake some assets on the final settlement chain. Say we're restaking ETH, or we're staking ETH or locking ETH into a contract.
Yeah.
And the staking network takes, let's say there's like 100 people participating with each different varying amounts. It samples them randomly based on the amount of stake they have and assigns them to a category. So it doesn't just randomly choose a leader for validating the whole block. It chooses a leader for the prover, a leader for the aggregation part, a leader for the DA, whatever. Getting that right is hard, right? Because you've turned this one-dimensional selection problem into a portfolio selection thing, right? Like I have to be kind of fair to choose each of these tasks. But the idea is still, you could imagine this world of doing proof of stake where you're actually picking multiple classes of these agents, assigning them for an epoch and the other thing that's important, I think, in the sequencer world that people don't think about as much in the layer 1 world is that in the sequencer world, you actually don't really need to be constrained to picking a new leader every block. You can play with the time element a lot more because you have the fraud you should have the fraud and verifiability guarantees. So you could have a longer epoch. So someone gets picked for a week to be the sequencer, right? And I think the two dimensions you have to play with in these kind of what these sort of modular networks will look like is A, how do can I convince people to stake a single asset, and then based on that single asset stake, you get assigned to each of these tasks that you have to be able to do. And maybe you indicate that like you maybe I don't have proving hardware, so I can, when I stake, I opt out of being selected to the leader for proving. I'm only the leader for DA and being a normal proposer. You could imagine a network allows you to express that preference. And then, you get selected like sortition style. But the thing is, I think there's going to be two dimensions. One is the set of tasks, like validate, block,
Sequencer,
aggregate, proof.
Yeah.
And the other is time. Like how long, what's my lease? Like when I get selected, what's my lease on that? If you think about the normal cloud computing world, that is how you pay for services, right? Like I rent a GPU node and it's only like hourly, or I rent a FPGA node and it's like you have to commit to at least 6 hours, right? Like a lot of these microservices and mini services, which are the sort of thing that inspired the modular world, they already do this type of stuff. It's just that they don't have to do this thing where they randomly assign people to the task to be fair.
Yeah.
Which is, that's where it's different in this world.
Yeah, and that in their case, they're providing the service based on those kinds of dimensions.
Yeah.
But in this case, you're picking the person or the agent to provide the service.
Yeah.
And they get compensated.
Exactly. Yeah. For each of the different subset of services.
That's interesting to think about.
So like, I think that's the final boss. The question is like, will there be a single network to rule them all in that world? And arguably restaking is the closest thing to that, because you can reuse ETH for doing all the services. In some weird shape and form, it like actually kind of is the closest to that final piece.
Interesting. Okay, so I want us to also talk about, sort of the announcement that prompted this interview, SP1. When I saw that, and I also had seen all of these other announcements, I was like, I think it's a really good moment to have Uma back on the show to go over it. Let's talk about what SP1 is and how that relates. And this is maybe where it's actually, I've had a bit of a hard time understanding how it relates to the other work that you've done. So yeah, what is SP1?
Yeah, so SP1 is a 100% open source ZK VM that, in short, if you want to use ZK, you can just like write Rust and then you get a proof. More technically, what SP1 is it is a RISC-V ZK VM. Yeah, it has really state-of-the-art performance for a lot of like kind of technical reasons I can't get into. And yeah, that's kind of like what it enables. And yeah, I think it's been very exciting for the open source community, for its performance benefits, for a lot of different things. And yeah, it's something that we're building at Succinct, and it will plug into our prover network eventually. Like that will eventually be like the best way to use SP1. So yeah, also happy to talk about that connection, because I think that has not been super obvious to people.
Yeah. I thought to me, it was kind of like the announcements came and they seemed like I actually had trouble linking them together. I think you've made a really good connection now for me from that Succinct platform to the prover network. And I mean, I guess I can imagine this connection, which is like with a really powerful, really like if a lot of proofs are being generated on a ZK VM using Rust, all of a sudden the volume is there to be able to like have a prover network, which would be like, yeah, you wouldn't want to then be doing all those proofs yourself. But it's almost like you did it like in a funny way. Like the prover network comes before the thing that would use it, right? Like the SP1 is using the prover network. Am I right? Is that the connection point?
Yeah. Like I think the prover network is like the base layer that like powers everything. And then like right now, the demand for the prover network, it's just like too hard to write a circuit to like want a proof. Like right now, even for us, to get to the point where we are consistently wanting proofs, we had to do this like horrible, terrible, like 3-month, 4-month circuit development. And now with SP1, we can just like write Rust in an afternoon. And then now we just like want proofs, like a stream of proofs for our application. So that's kind of how like we view SP1. It's like, it's like creating demand for the network.
Yeah.
And making ZK developers' lives easier. And also, maybe 1000xing like the total number of developers that can use ZK.
Totally.
But honestly, probably more than 1000xing. Like anyone knows Rust that can use
I mean, to be
can now
fair,
use
let's
ZK.
just do some back of the envelope math. The number of people who've probably written a ZK circuit is probably like under 200, would you say?
More now, maybe.
Okay, 500?
I think it's more now, but you're definitely under 1,000.
Yeah.
Under 1,000.
Yeah.
Okay. So 1,000x means you want 1 million ZK developers. I just want to give you concrete numbers to these claims, all right?
Yeah, like how many people do you think know Rust?
Yeah.
That's got to be in the millions. So yeah. That's gotta be
No, I
probably
think
1 million,
1,000's right.
Yeah. So maybe 1,000x. Yeah. I think it's just worth sometimes sanity checking these numbers. You know. And now I'm convinced.
Crazy. All right, so SP1, ZKVM, RISC-V under the hood. I think we should mention that there is another project. I am an investor in that project. Tarun, I don't know if you are.
Very tiny investor.
Okay, so this is RISC-0. So RISC-0 has been on the show a couple times. They have talked about like the RISC-V concept. To me, they definitely like pioneered that idea of like you can use Rust as is. Would you say is SP1 very similar to RISC-0?
Yeah, I think it's interesting because like we launched this and I think a lot of people are like, oh, it's so competitive, whatever. I think for us, honestly, like we really view SP1 as this like open source public good that like hopefully can be positive sum for ZK. Because like I think we just need more than 1,000 people to be able to use ZK, if that makes sense. So I don't view it as like extremely directly competitive. Like it is very similar. Now the reason we built it is that RISC-0, not all their stuff is open source. So in fact, like the core logic of like what are the constraints and blah, blah, blah is actually closed source. They have this like, I think it's called Zergen compiler that is closed source where they like write all like the logic of the VM. And then what's open source is like this auto-generated like the compiled version is all open source, but that's like, it's not modifiable by any external team. And so for us, like we were really curious about ZKVMs. We really wanted to use one even internally. But for us, like because we couldn't modify RISC-0, it was just a non-starter to even think about using it because it was just not performant enough. Like for a lot of the use cases we care about, like Tendermint or our bridging use cases or even a ZK EVM, because we couldn't modify RISC-0, there was no path to getting better performance. And so that was why we were like, okay, well, we need to build like a truly open source ZKVM where it's customizable, it's modifiable by the community. There's no like vendor or platform or lock-in risk. It's just all out there. And we kind of looked around because like we were like, okay, like has anyone built this? Like, and there just wasn't anything out there that was 100% open source, performant. And then we were like, okay, like let's go build this. So yeah, I think the biggest difference is that it's 100% open source. And because of that, because it's customizable, it's also a lot more performant because you can really like add these, we call them precompiles, to get the performance you want for use cases that are really important for us. So yeah, that was kind of the motivation.
Could we talk about the relationship between SP1 and Plonky 3 and like which components you used and how, you know, where the separation is, like in you know, just get a little architecture diagram because obviously you're using Plonky 3 under the hood, but it would be great to kind of understand which components since there's a lot of stuff there. Yeah.
So we are like really big believers in like open source. And I think we kind of think like the terminal ZKVM will be like this truly 100% open source public good. Because like the code has to be open source and be modifiable for, I think, honestly, for anyone serious to really use it. And we looked around at the landscape. We had been previously really big users of Plonky 2, which is this proof system developed by Daniel, Lubrov, and Brendan and other people at Polygon Zero. And we had been big fans of it. And Daniel had started working on Plonky 3. Plonky 3 is like this library / toolkit of like modular components that like people can use to build new proof systems, new ZKVM, stuff like that. Like it's kind of like this library toolkit type thing. And yeah, we looked at Plonky 3. We'd already been, of course, familiar with like the high level structure because it's similar to Plonky 2. And it's like super high quality code. It has like, you know, a good open source community around it. And so we built SP1 using Plonky 3. So for example, a lot of our constraints and stuff like that are expressed with like Plonky 3's air builder and things like that. And we've also contributed back to Plonky 3. Like I think there's a few PRs our team has merged into like upstream into Plonky 3 as we've like, because it's not like fully finished yet and they're always adding stuff. So we've also like contributed upstream back to Plonky 3.
Are you one of the first to be using Plonky 3 in production? Or is it already being used elsewhere?
Yeah, it's a good question. Who else is using it? I think there's a few other teams that are like using it or thinking about using it. There's this project called Valida that's also using it that Daniel and some other people are working on. Yeah. And then I think there's also a few other ones that maybe aren't public yet.
I see. Would you, kind of going back to the competitive landscape, are there any other products other than RiskZero that like are also in the same category? Because there are these other ZK VMs. There's other like Rust-based VMs that we've also heard about. Yeah, is there anyone else that you kind of would have been looking at kind of in that competitive space?
Yeah, I actually think, for example, the Andreessen team has been working on Lasso and Jolt. Like it's Justin Thaler, Sam Ragsdale, and Michael, I think his last name is Michael Z. I don't know exactly what his last name is, but they've been working on Lasso and Jolt, which has like a very similar vision. And I do think there are a few other projects with very similar visions, like some I think with like folding based approaches I've heard of, and yeah, others with like the Fry Stark approach. So yeah, I do think there's other ones. I'm actually honestly pretty excited about all of them. Like I think there's a lot of like techniques, for example, with Lasso and Jolt, there's like certain techniques from that could maybe be adapted back into SP1, that could help SP1 and like vice versa. So I think it's like really great that like, and I think all these projects I mentioned are like fully open source. So again, my view is like the best VM that will really stand the test of time will be like fully open source. And it's like really great for like the ZK community. And then I do think SP1 is like the best option out there today because like it just has like really great performance and it's fully customizable and things like that. But in the fullness of time, like for example, our prover network will support SP1. It'll support Lasso and Jolt. Like when RiskZero open sourced everything, it can also support RiskZero. Like it can support any of these options. Like we want to be fully modular and flexible because like we also know that's like the most sustainable given like how fast ZK progresses.
I know that when you released it, RiskZero did have kind of they wrote kind of a welcome to the neighborhood tweet, but also mentioned something about like performance. And I know the metrics that you had shared kind of compared performance on like a certain level, but they were talking about GPU. I don't know, what were you benchmarking on? Like, does it matter basically what hardware you're using, how well these will perform?
Yeah, I think one thing to say about benchmarking in general is like it's very hard to do benchmarking because it's such a multidimensional trade-off space. It matters what hardware you use. It matters like, are you benchmarking on a distributed cluster? Do you care about recursion? Like there's so many different factors. Like, do you have your own homegrown cluster using AWS? Are you using reserve pricing or spot pricing or on-demand pricing? Like, it's just very hard to do benchmarking. We really tried to do a very intellectually honest benchmark. So our benchmark was like on CPU, on the same machine, just run both VMs and then just look at the amount of time it takes on the exact same CPU, just end to end, run it through. I think that's the easiest way to benchmark because we just like compare on the exact same hardware and you just like look at the total time. I think they were saying basically that like they have like a GPU implementation and on GPU it's like faster or whatever, it has better performance. That was just like not really in the scope of our benchmark, if that makes sense. And there's like certain arguments for or against GPUs. Like for example, they're harder to get in the cloud because there's all these like crazy AI companies that really like GPUs today. GPU is also something we're kind of thinking about potentially adding to Plonky 3. Like maybe it'd be awesome to have it. It is just really hard to benchmark totally apples to apples. And I think they were just saying, oh, like we've spent a lot of time on GPU. So like, you know, we just want to like let people know that like that's like an option, for example.
It's just going back to the prover marketplace thing because it's almost like because the hardware and like what you're running these proving nodes on seems to matter. So it's like there's the prover marketplace, there's the demand for the prover marketplace, and then there's the hardware powering the prover marketplace. Do you have any sort of hardware play, or are you just sort of like, well, there's CPUs, GPUs, and apparently there's an ASIC now, but like, are you just going to say like whatever hardware is there, we're going to go with, or do you want to influence that? Is that sort of outside the scope of the prover network?
I think, yeah, the idea of the prover network is like any hardware provider can participate. So like maybe, for example, like the idea is like we'll support a variety of different proof systems and a variety of different VMs, right? And then we'll also support like any hardware provider, and like our marketplace/network will just be like this coordination layer where like the two parties can like talk to each other and communicate and participate in this like competitive auction or whatever. So I kind of view it similar to how like, you know how Ethereum provides this like layer for like the rollups to compete, and like a bunch of different rollups have made like really different choices in many different dimensions. And then Ethereum just sits in the middle and like coordinates like all the users and all the rollups and that activity. Like that's kind of how I view our network. It's like our network that sits in the middle. There's like hardware providers on one side. There's like applications using a bunch of different proof systems and a bunch of different VMs on the other side. And we sit in the middle and just like help coordinate that activity. So for us, for example, where we see like a gap in the market, we'll step up to fill it in. So like with the VM landscape, we saw like that, okay, there was this lack of an open source performant VM. So that's why we made SP1 to just like induce demand for this network. Because it's like, well, no one's going to ever use the network if like there's no good options for VMs, you know? And like similarly, I think if one day we're like, oh, like there's no good hardware providers, like maybe we have to like try to like jumpstart that, we will. But we have like no current plans for that. And I actually do think there's a lot of really great hardware teams. So I'm like really excited about like potentially some of them even like, you know, trying to accelerate SP1, or like maybe even someone external doing like the GPU thing for SP1. Like that'd be awesome.
Yeah, I'm trying to imagine if you would you partner with hardware, or is that just like provers can choose their hardware and you wouldn't have any say on that?
I kind of think if you're going to go for like the decentralized network, it's actually quite hard to pick one particular type of hardware. Like you really do need to actually have enough of a substrate that it's like anyone can plug in, provided they meet some standards. I kind of think having to be one particular hardware platform makes it like kind of hard to bootstrap in a lot of ways. Especially if the tasks have very different compute costs, right? Like the aggregation proofs might be cheap relative to the full block proof, right?
No, 100%. Yeah, I don't think like we'd have to partner with a hardware provider. It's like come hook in and like play in the marketplace, you know? Like that's kind of the goal, is it's like fully permissionless, fully open, decentralized. Like I think that's like the beauty of crypto, is like you don't have to ask anyone.
You may have to issue some points.
Oh no.
Proving points.
Proving points.
Proving points. Proof points.
I actually think, by the way, a very tiny again aside, I actually think one of the best ideas that hasn't been done and actually is really good for using ZK is doing point systems that are like loot boxes, where you don't know how many points you get, and like you get a ZKP that like some particular calculation was done to generate how many points you should get for participating. But it's like a ZK loot box. It actually is ZK, not just sync. You really want it to like hide.
Yeah.
Because I actually think you turn the point systems into a lot more of like a lottery game, and like I don't know, people love that shit, you know?
Yeah, I think they weirdly find that more fair. Chance.
I definitely think it's more fair in some ways, right? And it also would be public. The methodology is public because it's like this ZK. Wow. You can read the ZK circuit doing it, but it uses some provable randomness that can't be.
Pure casino. I love it.
I mean, it is, but these point systems are like casinos where you don't know whether the casino's floors will like suddenly be pulled under you, right? Like it is a little bit, there is some risk, right? I mean, look, I think there are a lot of pros of these point systems because they actually help the teams design, QA test their application, and they help the teams design which actions they want to reward and not reward, and figure that out iteratively instead of like, okay, we're only going to reward liquidity and like we can't change it ever. It's immutable forever. Which in 2020 made sense. But I think now that the existence of industrial airdrop farming is there, you kind of have to now have more levers at hand. But anyway, I think the ZK point systems actually has product market fit like tomorrow if someone builds it.
Yeah, someone should build that.
Yeah, someone should build it.
And then use the marketplace to generate the proofs. Although, wait, okay, question about the marketplace. This has also come up. When you have these prover marketplaces, doesn't it also screw up privacy? Like, can you keep things private if other things, like you're sending data to the prover network to make proofs? Like, I think it makes a lot of sense in the succinct context. The succinctness, like, or the, verifiable, like making sure that it's correct, but it doesn't seem to work as well for. Yeah, so that's what I've heard. Like, you have to FHEize it and then you ZK it.
Well, for privacy, I think basically the end game looks like this. You generate a really large proof client side. So basically you do like some client side proving. So there's this like prover verifier trade-off where if your verification time is large, your proof time can be a lot shorter. And so like you basically generate this like really long verification, short prover time proof client side, and then you go to the prover marketplace and you wrap that proof. So and then you like compress it and make it succinct, and then you turn it into something you can use on chain. So I actually do think the marketplace is still useful for privacy applications because of this like wrapping and aggregation stuff.
I kind of want to know what's next for succinct, but I also sort of want to know what you think is just next in ZK, because you're moving very quickly through these use cases. And I'm like, what is Uma thinking about now?
Yeah, I think with SP1, like, I mean, I tweeted about this, but I really feel like it's this like GPT-4 moment of ZK, because I think the really cool thing about it is like it finally has like the correct shape. Like, I really strongly believe, and this is probably non-consensus, like that every single application will use ZK in some form in the future. Like, every rollup will be a ZK rollup. Like, every bridge will be a ZK bridge. Every oracle will be a ZK oracle. And I think all of them are going to use ZK by writing normal Rust or like normal code and then proving it on a ZK VM, hopefully SP1, but whatever is the best open source VM. And then like coordinating on this like prover network marketplace to get like the cheapest possible proofs. Like, I feel like that to me is like the end game of ZK. And it's really exciting to see like all the hype around SP1, because like even in our Telegram like support group, or like just the number of things people can do is so great now. Like literally today, some guy was like, oh, I implemented like some Black-Scholes stuff using SP1. And that was just like not something that would be possible with a circuit. Like, writing a circuit was like so horrible. And so I really hope SP1 like catalyzes this like wave of like any developer can now use ZK. It's like really similar to GPT-4, because like before GPT-4, to do AI, you had to like do all this complicated stuff. You had to fine tune these models. You had to have all these expertise. Like, I was in that era. I was pre-GPT-4. I was like doing all that stuff. And then now with GPT-4, it's like anyone who's like a software engineer who can make an API call. I mean, not like you don't even have to like be a software engineer. You can just make an API call and use AI. Like, that's awesome.
To be fair though, the people building GPT-4 are still doing all the dark art hyperparameter.
Oh yeah. The people building GPT-4 are doing dark arts. Yeah, I agree. Yeah. And like similar to that, like we built SP1 and we had to like go through some pain, like it was very hard to build SP1. But now that we've built it, it's like anyone can use it. Any developer can write Rust and get a proof. And that to me is really exciting, because like even I've just seen internally using it is like magical. Like, stuff that used to take us months now takes an afternoon. There's like people in our support group, and finally I can just be like, oh, you don't even have to ask me questions. You can just like go write normal code. Like, it's so awesome. And so like I'm just really excited, because now I'm just like, okay, like let's take SP1, let's get like ZK embedded in every single app, like every single roll up, every single bridge, like whatever. It's like now so easy. And then let's build like this network to kind of like be the hosting and infrastructure layer of it all. So yeah, I think we're just like focused on that. Like, hopefully like this brings back like, the ZK bull market or whatever, because it's like now anyone can do anything with it. So it's awesome.
I'm telling you, the ZK bull market only comes back when you have ZK points.
Hilarious. How big is the team?
It's still pretty small. Yeah, it's like 10 people, but we are hiring.
Okay. What's next for the company? It's like you released this, but what is your next steps?
So we are hiring, because I do think we do need more people to like help build all this stuff. And yeah, I think for us, like, it's just like, let's take SP1 and like, let's make it production ready, like get on-chain verification, like, get it audited, whatever, like make it faster, make it more performant. And then also like start building this like prover network where like hopefully SP1 can be hosted, and like when other open source VMs come out, and like honestly hopefully they're faster, because I think that will just induce demand for more proofs, like integrate those into our network and like basically just start generating a lot of proofs. So yeah, I think that's just like our plan, is like make SP1 faster and then build out the prover network, and yeah, make sure that like all the proofs are getting generated by like, for the cheapest price possible. Yeah.
Is it all ZK VMs? Could like any of those rollups use it? Could any of like, I'm just trying to imagine who your customers could be for that prover network.
Yeah, I mean, the way we're going to build a prover network is to support any like proof system, any VM. So like
it could be EVM,
existing
ZK
rollups could use it. Yeah. New ZK rollups can use it. Bridges could, like anyone using ZK can use it, because it'll be like this very general modular thing. Like it'll be like hardware providers can opt into like who they want to like provide proofs for, and then like on the other side, like if you're an application, like you can just be like, hey, these are my binaries, these are the things I want to run, this is like the proof I want generated. So it's very general, like anyone can use it.
Cool. Tarun, do you have any last thoughts?
Nope. Excited to see what people build, and like I said, if you're ever thinking about building ZK points with SP1, let me know, because I have so many ideas for this. I have so many ideas.
Wow. That's so funny. I love it.
It's good.
I think the ZK
Tarun, you gotta write a tweet about this.
The ZK market just needs some degen energy, and I feel like SP1 makes it easier to have degen energy. So
no, I agree. Yeah, any degen can now do ZK. It's true.
Wow. All right. Uma, thank you so much for coming back on the show and sharing with us all of these products, all of these projects, and how they all relate.
Yeah, thanks for having me. It's been fun.
Thanks for coming on, and obviously super excited to see where this ends up.
Yeah, no, good to chat with you guys.
I also want to say thank you to the podcast team, Rachel, Henrik, and Tanya, and to our listeners. Thanks for listening.